Right, here we have a question where we're going to be modelling a trig function using R cos x plus alpha. So we're going to express 10 cos theta minus 3 sin theta in the form R cos theta plus alpha, where R is greater than 0 and alpha is between 0 and 90. Give an exact value for R and the value for alpha to 2 decimal places. So the first thing to realise is we're going to be expanding R cos theta plus alpha, and we expand that, we get a R cos theta cos alpha, and we get minus R sin theta sin alpha. Now if we compare that to the expression we got where we got 10 cos theta and we got a minus 3 sin theta, what we can see is we've got the cos bit here which matches with here, and we've got the sine bit here which matches with here. So therefore what we're going to equate is the R cos alpha with 10 and then the R sin alpha with 3. Okay, 10 will equal R cos alpha, doing the turquoisey bits, and then doing the light blue bits we're going to get 3 equals R sin alpha. Now we always know that R squared equals 10 squared plus 3 squared, so therefore R will equal the square root of 109. You can go through earlier videos or more thorough videos where we square all of this and we square all of this and we realise we've got cos squared plus sine squared equals 1, and we can take that out and therefore we're left with this. But you can learn this off by heart. It's always equal to that value squared plus that value squared square rooted if you want to take a shortcut. Where I would not recommend taking a shortcut is learning off by heart how to find the alpha. Now if we do this equation, equation 1, and divide it by equation 2, we'll get tan alpha because we've got sine alpha divided by cos alpha, and the r's will cancel, and that will give me tan alpha, and then we're going to get the 3 here divided by the 10 here, and therefore we can get alpha's inverse tan of that, which comes out to be 16.7 degrees. Now moving on, we're going to now apply this to this Ferris wheel problem where it starts here, goes up, goes down, goes up. The height above ground, h meters, starts turning is modelled by this equation, h equals, now this is a different alpha, not to be confused with that alpha, which a lot of my students did do, minus 10 cos 80 theta t plus 3 sin 80 t. So it's going to be taking this away from the alpha. Now we want to find a complete equation for the model. We know that initial time is 1 meter above, so at t equals 0, okay, b part 1, at t equals 0, we know that y will equal 1. Now if we put t equals 0 into this expression, so t equals 0 into here, 80 times 0 is 0, sine of 0 is 0, so this is all 0. 80 times 0 is 0, cos of 0 is 1, so this is 10. So we know that we've got 1 will equal alpha minus 10, because this bit's equal to 10 and this bit's equal to 0. So therefore alpha must equal 11. And therefore my model will be h equals 11 minus 10 cos 80 t minus plus 3 sin 80 t. And if we want to apply what we know from before to this, we know that this is just going to be the same as the 80t is going to be my theta. So I've got my r is going to be root 109, and I'm going to be taking this away because in here I've got a plus 10 and here I've got a minus 10. So I've got 11 minus root 109 cos 80t plus alpha, which is 16.70 degrees. That's for part 1. For part 2, hence find the maximum height of the passenger above the ground. Well, it's going to be when cos is equal to 1. So not 1 in this case, it's minus 1. Okay, because we're going to be taking that away. So it's going to be equal to 11. So for part 2, it will be equal to 11 plus the square root of 109. Which, when you work that out, comes out to be 21.44 meters. All right, so let's just remember, cos for the maximum height, we want this to be its maximum negative value. Cos's maximum negative value is -1. Cos oscillates between 1 and -1. So when we come down to, if we want to get to here, we're going to actually need cos to be minus, because we're going to then take this away. So therefore we get plus 109 as our biggest value to add on to 11 and get this maximum height. Find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. Now what you've got to realise is this plus 16 degrees has shifted the whole cos curve left. So when you've got your original cos curve that this has come from, this point has been moved to the left. So we're starting from over here. Okay, my first maximum height is going to be when cos is -1, which is just here. My second maximum height is going to be here when it's at 540. There's 360, there's 540. So I need to solve that this is equal to 540. So I need to solve that 80t plus 16.70 equals 540. So therefore t will equal 6.54 minutes. It doesn't say, it says to the nearest second, so we need to write that down in minutes and seconds. So convert that into minutes and seconds will give me 6 minutes and 32 seconds. So that times by 60 to get my 32 seconds. Right, moving on to part D. How would you adapt the equation of the model to reflect this increased speed? So if this is increased speed, we're going to want more oscillations happening in less time. And the key thing that affects that is this part of the equation, the 80 part of the equation here. Okay, and to get more of those in, that number needs to increase. So therefore, the answer to that is that we would increase the 80. Okay, in the formula. And there we have it. That's the final answer to our modelling question.